Welcome to qnawire.
A box contains 30 red balls, 30 white balls, and 30 blue balls. We're going to pick 10 of these at random without replacement. What's the probability at least one colour is going to be missing? Okay, so we're picking them without replacement, and the order in which I pick them doesn't really matter. We just want to know what colours we end up picking. Order doesn't matter. With these two rules, I can see that the base of this question is combinations. And the formula for combinations, n choose r, is n factorial over r factorial n minus r factorial. Although I'm just going to be using the combinations button on my calculator, because these are going to be some pretty huge numbers. Okay, so since we're looking at a probability, I'm going to make a fraction. On the denominator, I will have all possible choices. On the numerator, the number that meet our criteria. At least one of them has been omitted on the colours. So the denominator is every way to pick 10 from 90. 90 choose 10. Now, how many ways could I pick these so that at least one is missing? I'm going to flip that around. I'm going to apply the complement rule. What if I start at all of them and take away the selections where all three colours are present? Would that be faster? And actually, I don't think it would be. Yeah, I think it would be much faster to do this the intended kind of route. So intended, they might have intended the complement rule. So let's have a look at the different colour patterns. We could have only one of a colour. All red, or all white, or all blue. Let's get those. All red, we would ignore the others and say, okay, 30 choose 10. All white would be the same way, 30 choose 10. Same for blue. So I'm going to take this and multiply it by 3. So that's the number of ways to pick all of one colour. So 2 colours are omitted. How many ways could I omit? 2. Omit one colour. Exactly one colour. Well, maybe I omit white. I have 60 to choose from. I'm choosing 10. Maybe I omit blue. 60 choose 10. And same there. So this times 3 as well. So we have the number of ways to omit 2 colours, the number of ways to omit one colour. And of course, we can't omit 3 colours, otherwise we wouldn't be picking any at all. So if I can solve this, I'll have my answer. So I'm going to start doing that with my calculator. So I've got 90 choose 10, 60 choose 10, multiplied by 3, and 30 choose 10, multiplied by 3. And putting all of this in at once. I get 0.0396 to 4 decimal places. So there is the probability at least one colour will be omitted.